Thank you very much, Tim, and thank you for giving me the opportunity to speak here at this conference. My name is Lene. I might interfere with that one. You think that okay. My name is Lene Olesen, and I come from a company called Niras. It is a company located in Denmark, but we have a lot of different offices around the world and a lot of different projects. All the red dots here are our offices, and all the blue dots are projects we are involved in around the world. So this is an engineering company. I am educated many years ago as a engineer in chemistry and microbiology. And how we can say that we differentiate our engineering company is that we work a lot with sustainability. So if we are doing a road in Tanzania or a water cleaning facility in South America or a pharma company facility in Denmark, we always try to put in as much sustainability as possible in the projects. Okay, so I also have things to do in Danish standards. Even we are a small country, we have our own standardization organization where we have a mirror group for the TC209, the group that takes care of the 14644 ISO standards. I chair this group, and we have the whole industry in Denmark collected together in this area. I also have some things to do in our Nordic Society of Cleanroom Technology. It's actually we are 5 Nordic countries, but in this society we are Norway, Sweden, Finland, and Denmark. Iceland is not there. We do not know. They are very welcome, but they are not in our society yet. We hope they will join. And I am also involved in the ICCS. So that's I have a lot of things to do. Okay, so I will give this presentation on the microbiological aspects of these new technologies we see in the Annex 1. So the background is we have this Annex 1 update with a focus on a lot of new technologies that we did not see in the 2008 version. We have the RMM, rapid methods, we have isolators with water system, etc. And well, yes, the purpose for this new big annex is that we want a better success, I guess, with producing our sterile products. In my presentation here, it's not a very technical presentation as we have seen earlier today. It's more an overview and combining a presentation where I'll come around some practical examples of how of some of the new technologies that are come into the new Annex 1 and the ability to support the production, and what can we get out of it, and what might we lose going into using a new technology, and also something about how can we ensure and evaluate the efficiency of when we introduce a new method. Okay, so if we look at the new Annex 1, we have some very frequent words in there. I think all you who have read it will see that the risk is mentioned more than 100 times. I don't know how many times, but more than 100 times. We have a CCS mentioned as a new thing, also something like 50 times, disinfection 30 times, and automation only 10 times. So does it mean that it's not important with automation? Well, I don't think so. I just think that it's not mentioned that much because we use it as a basic technique already in many of our processes today. Okay, so these automation methods we know already more or less. We have a lot of automated aseptic processes. If we have, for example, a filling line in a grade A, we have wash of vials, we have filling of vials, and etc. We have a lot of our sterilization processes have been automated for many, many years. We have automated autoclave cycles, dry heat cycles, etc. We have also, we can use very well our data integrity and traceability by combining these systems together, ensuring that all inputs from, for example, environment and operators, etc., they are combined so we can have a fast overview. Also, we have materials handling and logistics, more or less, as small as bigger companies. I know in Denmark we are building a new facility which should be operator without any operator. So you just put in the things in one side and get them out in the other side. We don't know if that will happen in real or not, but it's the plan. And then of course you have smaller companies where it's very much manual at the moment. Then we have the training and qualification systems where we can have the operators that they know which SOP they need to read, which quiz they need to take. I'm not thinking of this quiz we are going to have afterwards, but a quiz in how are we doing in this company, how are you supposed to do if you need to gown or you need to do a specific operation. And also combined with the training that's given, and then you can have, say, the license for going into and do a specific process or thing in the clean room. We also have the isolator technology where we have often some of the same process automated as we have for the filling in grade A. Or other process going on in grade A, but it's also the decontamination process of the isolator that is automated. We have all our process controls that might give us the possibility to have some results, for example, the TUC in water systems. And we have our clean room monitoring and control systems that we can have as RMMs as well. And then finally what I have taken into this presentation is the cleaning, the sanitization and disinfection processes that can be validated with the focus to reduce microbiology and also, of course, cross-contamination. Okay, so when we use automation, so what will we get? What can we get out of it? We can ensure our reproducibility of our process. We can make it the same way anytime. It's more difficult if we have to do it manually. It can ease the isolation, as we have talked about earlier today or so. It's difficult to have the operators close to a product that we won't need to be sterile. So, and we can also solve a lot of complexity by giving an overview of the interactions between different processes, which interactions do we see and how can we control it. And then we also have the possibility to speed up our production. It can be by the process or it can be by we get faster results. Okay, so I have a few examples of where we can use automation and also which challenge do we see in using them. If we, for example, look into the Annex 1, if we look at cleaning and disinfection, if we look in Annex 1, 433, it says that we need to clean before we disinfect, and cleaning should remove disinfectant residues. So if we look in a clean room, an almost empty clean room, then we can imagine that it's possible to get somehow robust validation of an automated process in there. But if we go into an isolator, I could think that it could be a little bit more complicated. For example, we still need, of course, when the efficiency of the decontamination and also, of course, of the disinfection, it depends on what kind of disinfection or decontaminant we use. Also the cleanliness of the surface before we start disinfection, and of course the access of surfaces. So if we are in an isolator with a lot of, which these can be very compact, with a lot of things going on in a smaller area, it can be difficult to validate an automated cleaning process, because if we want to clean, sometimes at least before we do the decontamination or disinfection. So this is one of the challenges we can observe if we put in automation in this place. Another thing is if you want to introduce our rapid microbiological methods for different, it can be different situations, for example, the environmental monitoring, or it can be water testing. If we look at the environmental monitoring, we know that we can count possible culturable particles. Then I've not said too much. And we can do it in a way so that we can save our incubation time. We get a count and we think this particle is viable or potential viable. So this is quite a good method. I think you have a presentation of one of these methods tomorrow. And one of the challenges in here is that we can get the count and the knowledge that we have a potential culturable organism. It might be an organism that is able to grow, maybe it's not. Maybe it once could grow, but it's not able to grow anymore. But anyway, if we work up against Annex 1, then we have to identify everything that we find in our grade A and grade B. So here we have a challenge in putting in a system if we do not use all the, how can I say, all the possibilities with the methods and are able to do the identification. Of course you can do the identification, but you need to set the system up that you can collect the potential viable particle, and put this filter into incubation and see if you have a growth or not. And then when you have a growth, then you can identify it. So, but this is one of the things that could be challenging in putting in such an automated system if we cannot get the identification result out. Okay, another thing is water testing, pharmaceutical water testing, where we also could count possible cultural particles different ways. It could be a fluorescence method as the one for the EM monitoring, but it could also be by enzymatic methods or other setups that exist. Again, we save the incubation time. We get a count as soon as our system sees something that looks like an organism. But in here, we often have a possibility to get a sample from the water system, and we do not have a limit of 1 CFU, but maybe 10 CFU per 100 ml, and then we can take out a sample for testing and identification. So this is two different situations using a rapid method, but where we have different ways that we have to look at how we can ensure to fulfill the requirements. So how do we deal with these challenges when we introduce the new automated methods? We get some advantages and we get some new challenges. It might not be the same challenges we had with the old setup. Now we have to think new ways. So we have some risks. So that means that we need to know them, and we need to know how we can mitigate them, if necessary, if we think we need to mitigate them. We also have our quality. We need to, quality by design, we need to know our design, we need to know how, know our processes and our product. We can't just put something in a black box and something comes out, a product comes out in the end, and then we just test for sterility and says everything is fine. We need to know whole process of the product, what's going on, and what is the places where we could have a challenge. And then on this basis, we should have some control measures, and they should of course be robust and relevant. Okay, so how can we deal with these challenges? Well, we have a lot of quality by design guidelines that we could take into account, and we also need to use our risk assessment to identify and mitigate our risks. We need to, if we have an old process, get a new process. We need to go in and look at which risks do still exist and which are out, which new did we get by introducing this method, and of course also not only identify them but also rate them and say, is it better or is it higher? Where did we move the risk somewhere else? And then we need to implement some robust control measures, so we know that these tests we have in our whole process, that they are relevant and they are not. It can be difficult to leave some old control measures or controls you have made. I remember many years ago when the ISO 14644-1 was changed, and I was in a company where everyone were having a sample plant, and it was used for everything. It was used for monitoring, and it was used for classification. It was always the same sample points that were locations that were used. So it was a little challenging mentally for the people there, that they need to get rid of some of the sample plants and make some new ones which were more risk-based. So this is what we have to do. We have to go the whole way through our process to be sure that the measures are relevant. And then we can take our whole, we need to have our whole setup. We have our process and we have everything that comes in and that have an effect on our product, to and summarize it and to evaluate it in our CCS. I think instead of having the CCS being afraid of it or saying it's just something that we put in the cupboard, we should have it as a tool and use it instead. Okay, so my considerations, and just to sum up, is that automation by itself, it doesn't ensure any better quality. It only ensures reproducibility, and of course, if we have some luck with the design, it can be a good thing. So we can also have, if we if we manage our automation cleverly, we can lead to significant fewer points of risk, knowing which one are relevant and which are have high risk and which are of lower risk. And then automation can speed up our production evaluation, means that we have our combined system with, for example, the training setup. We can fast find out who can do which operations, and we can take decisions if we can set up a product for release or if we should discard it instead. Then I think that we should take, if possible, take quality by design and risk assessment. It must be our new best friends. When I say if possible by quality by design, is that often companies have not the possibility to redesign the whole thing. It's been done many years ago, so we cannot just say we close everything. No, we earn no money next 2 years because we have to redesign our product, our facility, etc. But I think when possible, put it in and use it, then for getting a better setup. And then I think, as I just mentioned before, I think we should use the contamination control strategy, the CCS, to give us the full overview, so that we're not having several pieces that are not connected. We don't know if we change something over here, how does it affect another part in the company. Okay, so I think that's what I had to say. Thank you for your attention and for staying. I know it's going to be the funny part now, but thank you anyway.